so we are going to do a review over constructing a not a perpendicular bisector, that's next. Constructing parallel lines. You've already learned this, so we're just going to show it to you one more time because seeing it once a lot of times is not good enough. So let's start with, take our paper, and let's put a point on line L. Place a point on line L, and then I want you to draw a line through your point, let's call it A. Draw a line through points A and P. So start like that, and I'll do it on the hover cam. Alrighty, so you placed a point anywhere you wanted to on line L. We named it A. And then you're connecting A to P. Now, you do need to be careful because P is a huge dot. And you could mess up the construction if you kind of go all different places through P. So go right through the middle of P when you do this. I'm going to put my pen on the middle of P because the dot is so huge. We need to change that. But go ahead and draw a line. So far, you've just got yourself an angle. If you remember, the basis of making parallel lines was using a certain vocab word. Do you remember that vocab word? Okay, so the vocab word I was looking for was corresponding angles. That is literally the basis of constructing parallel lines. We couldn't have constructed them if we had learned about that first. So what we did last time was we took this angle, we copied it onto here, we copied the angle, and then this, the bottom of that angle, that bottom ray, ended up being our parallel line. So we used corresponding angles to construct parallel lines. So I'm going to do this construction very quickly. It's just a review. You will not be required to construct on the test, but you will be required to know where the construction came from. So I'm going to start by putting my needle on A, and I'm going to make an arc. Then I'm going to put my needle on P, right in the middle of P, not anywhere, right in the middle, and I'm going to make the same exact arc. So right now, I just made identical twin arcs. I'm copying an angle. Now, I'm going to put my needle on one intersection and my pin on the other. Right now, I'm not in good shape. I need to change my compass setting. Still not in good shape. Let's see how this works. Oh, much better. Look, my needle's on one and my pin is on the other. When that happens, I can just slide it up here. And now I put my needle in the same spot, but in the corresponding position. Get it? And I can make an arc going this way. And that intersection right there is where my new line needs to go through. That's the bottom of my angle. So that's where my new line needs to go. No, mine's not perfect because that dot is so big. But pretty much got ourselves some parallel lines. I care less about you being able to do it yourself, but I care more about you knowing where it came from. Here's where the theorem, here's where it came from. Construct a line parallel. Here's what we used. If corresponding angles are congruent, then we have ourselves some parallel lines. So that's what I want you to take from this. I want you to take from, hey, if I want to make parallel lines, first I better construct some corresponding angles. I better copy an angle in the corresponding part just further up along the line, and we get parallel lines. Okay? Done? Okay. Now let's review the easiest construction we've ever learned. Let's review perpendicular bisector. Okay? So here we've got segment AB. We're going to construct the perpendicular bisector. So I'm going to open my compass more than halfway, make an arc, open my compass, same amount. I'm not changing my compass setting. Make an arc going the other way. And then they intersect twice, so I just need to connect the intersections. my pink line is my perpendicular bisector. Remember, perpendicular means I hit it, I intersect at 90 degrees. That's what perpendicular means, 90 degrees. Bisect means I cut AB in half. So this equals this. I cut AB in half. Okay, now what I want you to do on your perpendicular bisector is pick a point, any point. Everyone pick a point on their perpendicular bisector. On the pink line, yours is whatever color you made it. Pick a point. So everyone's going to pick their own little unique points. Everyone's picking a point. I will pick this guy, but you don't have to pick this guy. Pick any point on the line. Now I want you to measure AP and AB. You can measure it with a ruler or you can measure it with patty paper. You can compare them with patty paper. I'm going to go ahead and measure it with my ruler. So on my paper, AP is right at 5 centimeters. And on my paper, P to B, oh, perfect. P to B is right at 5 centimeters. So what we're realizing is we can pick any point on this line, any point, and it's going to be this fancy word right here. It's going to be the same distance. AP is going to be the same as PB. They are going to be equidistant from the endpoints of the segment. So you could have picked this point, this point, this point, any point on this line creates some congruent segments. It's the same distance. So I'm going to write that, same distance. Okay? So now down here, I'm going to write a sentence. You need to write the same sentence and fill in the blanks. Okay, so here's my sentence. Any point on, you fill in the blank, any point on wherever is equidistant from points blank and blank. So go ahead and see if you can fill in those blanks. I'm sorry guys, y'all pointed out something. I was measuring AP and PB. I'm sorry. I knew what I was doing. And I wrote it, y'all just didn't know. I wrote it correctly here, but this meant to be PB. I'm sorry about that. I was measuring this segment and comparing it to this segment. I wrote the wrong letter. Thanks for catching that. Okay, do you know what goes in the blanks? Any point on what? Any point on what? Yes! Good job! Any point on segment or line, let's do line, on line CD is equidistant, is the same distance from what and what? You are on it, girl. Is the same distance from points A and B. All right, that brings us to the perpendicular bisector theorem, which is there. Cool. You don't need to write this down anywhere. Just go ahead and listen. I'm going to give you a piece of paper later that will have this on it. Not today. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And we pretty much just wrote that on our paper already. Okay? Okay, so now we're going to pretend that we have a graph. We have a graph on the back of our notes page. What if we need to construct the perpendicular bisector, but we cannot use a compass? How could we construct the perpendicular bisector on a graph? This is called coordinate geometry. So, perpendicular, when we're talking about a graph, we learned that perpendicular really just means opposite reciprocal slopes. So, we could find the slope of our segment and calculate the opposite reciprocal. Bisector really means go through the middle. The geometry word for middle is midpoint. So if we want to find the perpendicular bisector of a segment, let's pretend it's this segment right here, we need to find its midpoint, and then we need to find its slope. And we can go opposite reciprocal slope and perpendicular bisect. Okay? So flip to the back of your notes page. Flip to the back and go ahead and plot these points. Plot A at 1, 1 and B at 7, 5. So A is at 1, 1 and B is at 7, 5. It said to do the whole segment, so we're going to use our straight edge and make that segment. So now our job is to draw the perpendicular bisector of AB. So let's do the strategy we talked about. Let's tackle the bisect part first. Bisect means you better go through the midpoint. So what I can do is count my rise and my run. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And I can go half the rise and half the run. So instead of going up 4 over 6, I'm going to go up 2 over 3. And I land right there. That is my midpoint. Midpoint, check. Now let's do the perpendicular part. I know my slope, okay, I rose 4 and ran 6. So I know my slope is 2/3. I want the perpendicular slope to that. So opposite reciprocal, -3/2. So I'm going to start at my midpoint and I'm going to count a slope of -3/2. So I can go up 3 over 2, up 3 over 2. I can go down 3 over 2, down 3 over 2. And then I can connect the dots. And I had just drawn, not constructed, but drawn the perpendicular bisector. Now let's write the equation of that pink line. Let's write the equation of the perpendicular bisector. We're going to stick to slope-intercept form. So y equals, well, here's our m. We found it. mx plus, where did it hit the y-axis? At 9, if you count it. Y equals mx plus b. Y equals -3/2x plus 9. The last thing we're going to do today is a proof. Why not? We're in geometry. We should be proving things. All right. When we write a proof, we're going to start with the given. That's how we're going to start. How do you start a proof? You start with the given. Let's look and see what we're even trying to do here. Given. RS is perpendicular to CD. So they gave us that RS is perpendicular to CD. This part they gave us. Okay, so we know those are perpendicular, and we know that these lines are parallel. So we want to prove that, hey, if these are parallel and these two are perpendicular, we're trying to prove that these two are perpendicular as well. That AB is perpendicular to RS. And it's common sense, right? It totally makes sense. If these are parallel and this is perpendicular to this guy, then it's also going to be perpendicular to that guy. Makes complete sense, but we want to prove it formally because that's a very mathematical thing to do. So what we're going to start with is one of the givens. We're just going to copy we're going to plagiarize the given. Segment RS is perpendicular to segment CD. Why are they perpendicular? It was given to me. Given. That's the reason. Okay, now we are going past the given, and we're saying, oh, I know that if they're perpendicular, angle 1 must be 90 degrees. But then we have to write why it's 90. We have to know why. Why is angle 1 90? Well, because of the definition of perpendicular lines. We know perpendicular lines are not lines that intersect at 90 degrees. So we knew they were perpendicular, then we said they're 90. Why is it 90? Because of what a perpendicular line is. Okay, they're giving us a hint. The next one is given. So let's write the next given. AB, line AB, segment AB, is parallel to segment CD. So all I did was copy from above. All I did was copy. Okay, now we need to make another statement. And we're going to use the corresponding angles theorem. Well, if these are parallel, then don't you agree that these two are congruent? Because of the corresponding angle theorem? Okay, so that's what we're going to say next. Angle 1 is congruent to angle 2. Well, if angle 1 is 90, and angle 1 is congruent to angle 2, then don't you agree angle 2 is 90? Why is it 90? Because of substitution. I substituted out angle 1 is 90, 1 matches 2, so angle 2 is 90. Sometimes people call this the transitive property. I just wanted you to know in case you saw it written that way. So I would have called it the transitive property, but the textbook said substitution. Okay, finally, you always end a proof with what you were trying to prove. We were trying to prove that segment RS is perpendicular to segment AB. And the reason is, well, we just said angle 2 is 90. If angle 2 is 90, then those segments are perpendicular. Definition of perpendicular again. So we reused it. It's happened twice in our proof. I wouldn't stress out about proofs yet. We're trying to get you used to them. We're trying to expose you to proofs because in a couple units you will be required to write proofs yourself. But not yet. We just want you to see them.